Hello everybody, welcome back another technical demo around the Quarkus application. My name is Daniel. Today I'm going to showcase how to develop reactive messaging programming with the Quarkus AMQP data services. Let's get started. In this demo architecture, we're going to implement two different applications which will communicate with the AMQ broker. And then each application will consume the messaging from AMQP queue, but also send the message to AMQP queue, but we're going to use different AMQP queues. As an example, the core producer will generate a random ID and then send to quad request the name of the AMQP queue, and then quad processor actually consume that generated random ID. In the meantime, you can actually see the pending message on your web browser. And then quad processor will send random prices to AMQP. The name is quads. And then lastly, quad processor consumes the generated random prices based on random ID and then sent to the web browser and the end user using server-centered event. So there's a two takeaway in this demo architecture. We're going to develop two applications to communicate with the AMQP queue, and each application will consume and send the message to AMQ broker. And most important thing in this demo, traditionally you need to install AMQP broker server on your local machine, or you're going to use a remote AMQ broker, or you can also run AMQ broker as a Docker container on your local machine using Docker Compose or the Docker CLI, something like that. But Quarkus actually enables the developer to use dev services based on test container, which means when you develop reactive messaging programming based on AMQ broker communication, the Quarkus automatically stand up AMQP container based on test container automatically, which we call the dev services. And when you stop your application runtime, such as Quarkus dev mode or even modify your unit test, the dev services for AMQP container will be terminated automatically. Okay, let's get right into the demo, how it works. So I'm going to use Quarkus AMQP Quick Start today, but I'm going to a little bit add a new application code, how to develop the messaging programming, try to use AMQ broker here. So as you see, there are two application projects. One is AMQP processor, the other is a processor. Let's get started with the AMQP processor first. Go to the processor, and then first of all, we're gonna just check it out, the PalmXML, which is version 223, the latest one, and then we're gonna use a reactive messaging AMQP extension, which allows you to develop reactive programming. So first of all, we're gonna just create a new resources file, implement the endpoint processing. For example, we're going to define the endpoint here, the path clause, and then we're going to actually use a channel to send the message into AMQ broker, which name is quad request, and then we're going to use the emitter to send the messaging to AMQ broker. And then the other one channel is quad, as you already saw in the demo architecture. This is for consumption your messaging when after quad processor generated new random prices. So here is the quick overview of the quad Java beans, the return type. And then the one interesting part is the register for reflection annotation, which allows you to include this Java method and a field when you build nav compilation. Without this annotation, the Quarkus will remove the field and the method during dead code elimination. Okay, so go back to the quad resource file, and let's keep going on to develop the rest of the logic here. So I'm going to define the get method for presentation and produce type like a server-sent event along with our demo architecture, because this application sends the random price to application like a browser. And then here is the multi-quad, is how to consume your new random price from AMQ broker. All right, the last thing is the return the application, the result, end user the access the endpoint using web browser. that web browser endpoint actually call this post method, which allows the application generate a new random ID and then send the new random ID message to AMQ broker using emitter and return the UUID with the string type. That's it. And then we're going to add some required configuration in application property. So first of all, we're going to define outgoing connector, and a Quarkus requester is exactly the same name we define the channel annotation. And then we're going to use a small right AMQP broker. And the incoming Quarkus channel should use the same small right AMQ connector as well. That's it. Now let's move on the processor. Let's try to implement processor, and as you see, we're going to use the same core Java bean as a return messaging type, and then we're going to try to create a new Java class called processor. First of all, we're going to define the application scope Java bean for this application method and class, and then try to use random because we're going to generate the random prices along with the random ID. Then we're going to use incoming, outgoing annotation. So the channel name, request, and quote, and then we actually using blocking annotation because we not going to allow the caller to run this thread for the method. All right, so the processor method just sleep just 0.2 seconds, and then create a new random ID and like a random prices, and then put in the messaging broker like using outgoing and channel name. So define that specification into application property. First of all, we're going to set up the incoming channel connector, same thing, small right AMQP, and the incoming address. This is actually we define in processor application, the Quarkus request channel name. That's it. And outgoing is the same thing. So here is a traditional way to run AMQ broker on your local machine, like a developer local environment. So one of the popular way to run container like a Docker Compose, you can define AMQ broker. For example, the Quay, we actually using AMQ broker from Artemis from Red Hat side. So this is how to use AMQ broker to stand up, but we're not going to use this traditional way. Instead, we're going to use a Quarkus dev services. Let's try to start my Docker engine on my local machine. As you see, there's no container is running at this moment. So first of all, I'm going to run the Quarkus application using Quarkus CLI, like a Quarkus dev. I'm going to run two different applications, producer and a processor. You run the Quarkus application as a dev mode. The Quarkus is try to run dev services because we already using AMQP extension, as well as we already define relevant configuration on application property file. So as you see here in the logs, the find the Docker environment and then try to map your local host, and then the AMQP Artemis broker image is starting. It's automatically pulling down on your local machine and started during dev mode. And this the AMQ receiver is connected to the sender. So and the other application you got the same to connect to Docker engine and then pulling down the AMQ broker image and then connect to the message. When you go back to Docker dashboard, you can find the test container already downloaded and they're running on your local machine for your test container based on unit test. Let's try to open new web browser and then to test, local test. But for that, when you press D on your runtime environment, it's automatically open your dev UI. And when you go to Reactive messaging channel, you can find the two channel we actually define in application side. So this is a Quarkus and a Quarkus request for incoming and outgoing. And for outgoing, specifically, we're going to use emitter to send the messaging to AMQ broker, which with the name of Quarkus request channel. All right, back to the UI, and then you can find more detail of the reactive messaging AMQP connector, and you click on the documentation icon, you can find all detailed documentations. And then let's try to access the endpoint, like post HTML, and then click on request quote, and it actually trigger the post method we define processor application, and then just 0.2 second pending and automatically consume the generated random processor from processor application. So it's a pretty simple Java application, the processor and the processor, each application try to consume and send the message to AMQ broker. And most important thing with the Quarkus, you can have dev services benefit when you develop AMQP messaging application programming on your local machine. You don't need to worry about how to run and which version AMQ broker you actually run to communicate your application side. Quarkus will take care of it for you, and you just need to focus on reactive application programming with the AMQP broker communication. Thank you for watching. Have a good rest of the day.